In this next part of 4.1 and 4.2, we're going to look at applications. So if you remember the very first part of this section, we talked about when something is growing in a value proportional to a specific value, that indicates exponential growth or decay. So in this case, if we're growing, it's going to indicate exponential growth. So when I read this problem, it says, what is the present day value of a piece of real estate that will be worth $520,000 in 10 years if the real estate grows in a value proportional? So that is my keyword here, grows in a value proportional to the value of the estate and at an annual rate of 5.25%. So this tells me I need to use this amount equals the initial times e to the RT. So the PERT formula is what I need to use. So what I'm trying to find, what is the present day value? That means that's your initial amount, because what it's going to be worth, or it'll be worth 520,000 after this time period with this rate. That's going to be the total amount. So really what this question's asking when it says what is the present day value, this means we're really going to find what's the initial amount that you'd have to put in. So we want to find the initial amount. And if you look, this is the future amount or the total amount. So this is going to be A. And then our time period is 10 years. So that's going to be your time. And then rate is going to be this 5.25%. But we're always going to write the decimal. So we're going to just move that decimal 2 places over because we don't want it as a percent. We want to convert that over to a decimal. So it'll be 0.0525, what we'll be plugging into the formula. So now what we can do is we can go ahead and just plug everything in. So 520,000 is the amount that it's going to be, the total amount. We're trying to solve for P. E, remember, is just a number. It's like 2.71. It's an irrational number. We have our rate is 0.0525. And our time period is 10 years. So we substitute in, and then we're just trying to solve for P. So we got to get P by itself. So next step is I'm just going to combine these numbers up here in the exponent. So we have P times E raised to the 0.525. And then we're trying to solve, so really all I'm trying to do is get P by itself. And remember, E is just a number. So what I'm going to do, I'm going to divide both sides by this E to the 0.525 because that is just a number. You can put that in your calculator. So I'm going to divide both sides by that. And now I'll be left with P. So for P, so you just put that in your calculator and you end up with 307,609 and 79 cents. And that is the present day value, meaning that's how much money would have to go in now so that in 10 years it would accumulate to 420,000. So then let's look at some other examples where it's similar but the solving part's a little bit different. So the rate at which a new SUV's value decreases directly proportional. So again, as soon as I see that proportional, so value is decreasing proportional to the value. That indicates use that PERT formula. So then we start looking at the rest of it. So it says it's decreasing directly proportional to the value of the vehicle at any given time. Suppose that 6 months, so there's our time period, after a $42,900 SUV is purchased, an insurance adjuster values the vehicle at $39,700. So this right here is the starting amount. That's going to be our initial. And after 6 months, it's going to become the $39,000. So what we need to figure out, it says, what will the SUV be worth after 2 years? Well, we need to figure out the rate first because I don't know. It doesn't, it just says that it decreases directly proportional, but I don't know the percentage. So I do know though the starting amount and then what it became after 6 months. So what I can do is plug in and find the rate. And then once I know the rate, then I'll be able to find after 2 years. So this is actually going to be a two-step problem where the first thing you're going to have to do is you're going to have to find the rate because that's not given to us this time. So I'm going to use my formula and I'm going to plug in everything I know. So it becomes, so the current value after 6 months is the 39,000, but it started at, so my initial value was the 42,900. E, and I don't know R, so I leave it as R, and then T is 6 months. So if we're gonna do everything in months, if I use 6 months here, that just means when I go to do this 2 years, I need to make sure I convert that over to months. So that's going to be 24 months since I'm using months here. Otherwise, you would want to make this into years, so you could do 0.5 up there if you're going to stick with the 2. So just whatever unit you choose, just make sure you're consistent with it. So then from here, what I need to do is I need to get R by itself. So now the difference is R is part of the exponent, so I can't just divide by e to the 6 because the R is attached. So instead, what I need to do is let's work on getting R by itself. So I'm going to first just divide out this 42,000 so that we can get rid of that. So I'm going to divide that out. And I'm going to leave this as a fraction, so it's going to become 397 over 429 equals E, and I'm going to just rewrite that as 6R. So now, if you think back to the first video on this section, we worked on how taking something like this and converting it into log form and using logs to solve it. So if you think about like when something's raised to the third power, what you do is you cube root it. If something's raised to the second power, you square root it to undo it. In this case, our variables are exponent, so we can't take like the rth root of something, like that's not a thing. So what you do is, in order to undo this exponent that's a variable, you're going to take logs. So basically you're going to apply the log to it. So what I'm going to do is I'm going to make a note here that I'm going to convert from exponential form to log form. So that means I'm going to take this and it's going to become log base E, because the base is E. And remember, the exponent is going to equal the log, so 6R is going to be over here. And then the 397 over 429 is what I'm taking log of. And then remember, whenever it's log base E, that's really the same thing as ln. So this is why we talked about all of the converting, because in a problem like this, you have to be able to convert to be able to solve it. And then from here, you can just go ahead and get R by itself, because now I have, this is just going to be a number I can put in my calculator. So really all I have left to do to get R by itself is just to divide by 6. So I get, and then this all goes into the calculator, so I get R equals negative 0.01292. So that's the rate, and it should be a negative because it's decreasing. It said up there that it was decreasing, so that's why I'm seeing a negative value. So then what that means is, for the second part of this problem, if I want to find the value after 24 months or after 2 years, I now know that the rate for this situation is this negative 0.01292. So then I can use that in addition to the starting amount of the SUV to figure out, well, after 24 months, what's the new amount going to be? So we're going to find value after 24 months. So I'm going to use my same formula, but now I'm going to use this rate, now that I know this rate. So I'm trying to find the amount, so I'm not using the 39,000 anymore, because that's the amount after 6 months. So since I'm changing the time period, I'm changing the final amount. The starting amount is still going to be the same, so that's going to be the 42,900 E, but now I'm going to plug in this whole decimal here. So it's going to be E to the negative 0.01292. Time period is 24 months because we solved for 6 months, so we have to make sure we're staying with the same units. So instead of plugging in 2, I got to plug in 24 months because I used 6 months to find the rate. And then this, I can just put this whole thing in the calculator, get a number, and I'm getting $31,462. I don't know what happened there. $31,462.28. So make sure for these money problems too that you're just rounding 2 decimal places. It doesn't make sense to have 3 decimal places or 1 decimal place because we're talking about money. So you just automatically do 2 decimal places for those. So that's that. And I mean, that makes sense if you think about it. So you started at 42,000. After 6 months, it went down to 39,000 because usually you see the bigger drop within that shorter time period. And then after that, it went down to 31,000 within 24 months. So that seems pretty reasonable. So then for part B, this is another type of question you could be asked where now it's saying, well, how much or how long will it take until it's under $10,000? So basically now we want to take our formula with the rate that we know and we want to figure out, well, when's it going to equal 10,000? So if we figure out when it's going to equal 10,000, then any period longer than that time is going to be under 10,000. So what I'm going to do now is I'm going to set my amount equal to 10,000. So basically I'm using this formula from up top where I have the 42,900 E, and then I already know my rate now because that rate is consistent for this entire problem or for this entire scenario. And T, I don't know the time period, so I'm going to leave that. So what I'm going to do is I'm going to plug in 10,000 because if I can figure out when it's going to equal 10,000, well then I just know that the time period would have to be a little bit longer and then it'll be under 10,000. So first thing, trying to get T by itself. So this is going to be very similar in how we solve for R because T is an exponent. So it's pretty much the same idea. So let's start by getting the 42,000 on the other side so we don't have to worry about that. So we end up with 100 over 429. Again, leaving that as a fraction is going to be important. And we get E to the negative 0.01292T. And now we need to solve this. So we need to get that exponent. We're solving for an exponent. Anytime you have a variable as an exponent, the way to undo that, remember you can't take the Tth root, there's no such thing, you take the log, you apply logs to it. So we're going to take this and we're going to convert it from exponential form to log form. So that means I'm going to have log base E of the 100 over 429 equaling the exponent. And then from here, this is the same thing as saying the natural log without the base E, because that is the log base E. And then we can now get T by itself by just dividing by this entire decimal. So those are gone. And I can type that entire thing into my calculator. And when I do that, I get 112.715. So that means at 112.7 months, we're looking at this car equaling $10,000. So basically, if we just round that up to say 113 months, um, otherwise you would have to, you can't round down, you can't say 112 months, because if you say 112, it won't quite be decreased down to 10,000. So since it takes 112.7 to get to 10,000, since it's decreasing, you're trying to figure out when it's less than that. The more time you add, the least this number is going to be. So, or the lesser this number is going to be. That's the word I'm looking for. So the total time period, I'm just going to say about 113 months. Or if you want to convert that back to years, you can just divide that by 12. It's about 9.5 years. You don't need to worry about exact year and month and all of that. Just give an approximate for that. So that would be the answer to the question. So it's just using that formula whenever you see that proportional to a value. Something's increasing or decreasing proportional to a value. You're using that formula and then you're just solving. So you either have to use logs to solve or you could solve just by dividing.